Morning. Today is Monday, January 31st. All right, today we are going to review week 3 as we do every Monday, looking back at the week before. Then our activity today is a virtual lab. It's called Tough Tools. I will walk you through how to get to the website for that. And then that is your submission today. This should be done by midnight tonight. And then for homework to get prepared for class on Tuesday, we'd like you to read, highlight, and answer the questions on pages 136 to 140. And then we are going to be quizzing on experiences 3 and 4 in investigation 4 that we're doing this week on Friday. All right, so let's take a look at our module for this week. All right, so let's review. What did we do in week 3? All right, here we go. Okay, so we started out with a demo with temperature and ice melting, key takeaways, and then we looked at some video animation on phase changes and the way particles move. Biggest takeaways from the demonstration is that the melting point and freezing point of any substance are the same temperatures. And for water, that would be 0 degrees Celsius. The boiling point and condensation point are also the same temperature for any substance. For water, it's 100 degrees Celsius. So what we're going to have is the difference between melting and freezing is the direction of flow of energy. Is it going in or coming out? Same thing with boiling and condensing. The temperature itself of that phase change is the same. All right, then we looked at this activity, analyzing a phase diagram. So this is the diagram we were looking at. All right, big takeaways. One, the triple point. The triple point is where pressure and temperature allow for solid, liquid, and gas phase to coexist for the substance. And that is right here that I'm kind of circling around. It's the intersection between the two larger lines. So each line represents a phase change. So from the triple point up is line X. On the left side of the line is a solid. On the right side of that line is a liquid. So that would be the melting point. Line Y going from the triple point up, the top above line Y is liquid. Below is a gas. So that would be the boiling point. And then from the triple point back to the corner of the graph is line Z. Above is the solid phase. Below is the gas phase. And that would be the sublimation phase for the substance. All right, so we took a look at our notes, which of course is our reading in the book. So big takeaways from this section of the book. All right, so this is a partial phase change diagram or graph. So the flat line in the middle right here is where we're going to have two states of matter exist at the same time. There is no temperature change, which is why it's flat. All of the energy is going to moving the particles away from each other to get to the next phase if we're heating up. Then slope lines, we've got one on the left, one on the right. This is where we are in only one state of matter for the substance, and all the temperature kinetic energy is going to increase the temperature. So what we have is if we increase the kinetic energy, we're increasing the temperature. And so we can see that slope go up. And in our liquid phase and our gas phase, that's exactly what we're doing. We're increasing the kinetic energy, which increases the temperature change. All right, then on our next page, this diagram right here, we mentioned at the beginning on that first slide, melting and freezing, going from a solid to a liquid, are at the same temperature. It's the direction of energy that's different. And then liquid to gas, again, you're looking at the same temperature for a substance. It's just the process, and we can see the arrows pointing two different directions, showing the energy going two different ways. All right, on the next page, when we're talking about heating a liquid, we want to keep in mind that we're breaking particles apart, not breaking actual molecules into their separate atoms. We're just moving particles away from each other to get to the next phase. All right, and then finally, for this note section, we had evaporation and condensation. Evaporation happens at any temperature and only on the surface. We can see that written right here of your substance. Evaporation is not boiling. Evaporation is particles that have enough energy on the surface to go to the gas phase. Boiling is adding enough energy for all particles within the entire container to go from the liquid phase to the gas phase. So evaporation, again, is not boiling. All right, then we took our quiz. A couple of takeaways. One, it's important to complete all activities assigned so that you're prepared. Second, we took the quiz on a Thursday, which means you have 1 week to take your second attempt or take it at all if you haven't taken it yet. The quiz is still open until this Thursday, which is February 3rd. Quizzes are not going to remain open all semester. You need to complete them within that week time frame to earn credit. If not, you're not earning any credit. So make sure that you keep track in there. You're looking at Canvas and watching these videos, and you know when assignments are due and when we take quizzes. All right, and then finally, on Friday, I was at bowling, and I had you do an in-class activity. We'll take a look at this on Tuesday. The important takeaway is to do what I'm asking you to do, whether I am here or not, so that you are continuing to learn something and then earning credit for your assignments and preparing for the test. All right, so that was our week, last week. Now for the activity. So we're going to hit the next button, and you're going to see a page that says Virtual Lab Tough Tools. So first thing I want you to do is you're going to click on this link, which is going to bring you to the activity. All right, or it's supposed to. Okay, we'll try it one more time, and if it doesn't work, I'll show you something else that may work. And I think it's going to load. Here we go. Okay, so we're going to go to the lab. So on the printable copy that we have on the bottom of the page, you can print it out, or you can see the copy is right here. So if you're absent, you can print it out, or you can look at it here and do it electronically. So you're going to read through. So hit the scenario tab. You're going to read through this. So what you're doing is cutting into solid pieces of metal at high speeds requires tough tools. The cutting tip must be hard enough to withstand high pressure without chipping, and the friction involved generates a lot of heat, so the tip must withstand high temperatures without melting. So what you're going to do today is evaluate the properties of 3 different solids to see which one might be the most useful for making high-speed cutting tools. All right, in the lower right-hand corner, this next is blue, which means you're ready to move on. All right, so then the investigate section. So what you're going to do here is you're going to select the items on the lab bench to learn more about each solid and the tools that you're going to use. So just click. You can see how it's outlined in yellow. When you click on it, you'll get that information. And then you can click close. So you'll do that for the silicon dioxide, naphthalene, cobalt-2 chloride, the foundry, which is this big thing at the top, and then the conductivity tester. Once you've learned about those, you're going to click next. And then this is your analyze portion. So I want you to notice there are 2 dots at the bottom. So the first one is blue. That's indicating we're on this page right now. And there's one more page before we can move on. You'll notice the next box is white, not blue. So once you click to the next page to read that, you'll see it lights up. All right, so to collect your data, here's what you're going to do. You're going to take your substance and you're going to bring it over to whatever you want to test. So this is testing the melting point of the silicon dioxide. So you're going to then press play, and it will keep going until it gets to the melting point. When you're ready to do the next substance, hit reset, and then you can pick the next one and do the same thing. Then when you're ready, you'll do the electrical conductivity. The electrical conductivity tester is not broken. If you see 0.00, it means it's not conducting electricity. So once you've collected all of that data, you have a data table on the paper, which I will show you. This is what you're filling in for your melting point and then the conductivity test. Once you're done with that, you read this next page, which is also on your hard copy, and then you're done with the SAVIS site itself. So you can go back to your document, answer the questions there. Once you're done, you can go to step 2. Step 2 is the submission for this assignment. I'm going to see if we can show you what you're going to see. All right, so here is the lab link again if you need it. And then here is a video if you're having trouble reaching the Savvas site, you can go through that. All right, so you're going to hit begin and you're going to answer the questions. It'll ask you to put in some data and then analyze what you already had written down on your paper. Submit this when you're done. And if you're submitting it past the 31st, make sure to fill in the submission late link so that I know it is late and why. And then we'll go from there. All right. That's Monday, January 31st.